Monitoring systems are designed to tell us when things go wrong. Tools like Datadog, Dynatrace, or standard Splunk dashboards watch for a critical threshold to be crossed. Only then do they sound the alarm. Once that alert fires, a rigid chronological chain begins. A human operator gets paged, logs in, and begins the slow, manual process of troubleshooting, hunting for the root cause while the system degrades. This reactive cycle leads to an industry average mean time to resolution of 1 to 2 hours. During that window, service downtime is actively accumulating, service level limits are breached, and customers feel the impact. Every minute spent in this loop adds to the total impact. Waiting for a system to break before deciding how to fix it means that by the time an operator responds, the damage to the user experience has already begun. What happens to that entire operational sequence if we slid the timeline backward, predicting the exact moment of failure 15 to 60 minutes before a breach ever occurs? This is Whisper. It is a proactive, agentic observability platform engineered natively on Splunk Enterprise. Instead of reacting to an outage, Whisper detects early telemetry trends. It forecasts the specific minute the system will fail, generates an AI-powered brief with a root cause hypothesis, and provides the operator with a one-click automated remediation, all before the system actually breaks. The goal here is complete preemption. The outages simply never happen, leaving a clean audit trail proving the prevention. To understand how this works, we can look at the system architecture. Telemetry, which includes live metrics, structured logs, and distributed traces for multiple microservices, is ingested directly into Splunk via the HTTP event collector. The Whisper agent reads this index data back through parallel channels, establishing connections using the official Splunk Python SDK and the Splunk Model Context Protocol, or MCP server. This data feeds directly into the CDTSM-inspired forecasting engine. It uses zero-shot forecasting, meaning it requires no prior training, to calculate trend decomposition and hourly seasonality, projecting metric values up to 60 minutes into the future with 90% confidence intervals. Utilizing these communication layers, the system functions as an autonomous engineer operating continuously inside the Splunk ecosystem. We can see this exact process play out in a live environment. If we inject a slow query spike onto a database proxy microservice, we simulate a system beginning to degrade. This chart tracks real-time metric health. While the current data point remains in the safe zone, the forecasting engine instantly maps the trajectory. A dotted projection line tracks the steep upward arc, identifying exactly when it will cross the critical failure threshold 30 minutes from now. The system immediately calls on Google Gemini 2.0 Flash. Synthesizing the log and metric context gathered through the Splunk MCP, Gemini generates a pre-incident brief, displaying a highly probable root cause hypothesis alongside a precise recommended action. The human operator reviews the brief and clicks once to execute the remediation. The metric immediately normalizes, flattening out safely before the predicted breach time arrives. The problem is resolved before the first user experiences a delay or an error page. This proactive loop applies to cybersecurity with the exact same logic. The agent correlates incoming data against 5 specific detection rules, mapped to the MITRE ATAC framework. Whether it is a brute force login attempt or early signs of data exfiltration, these checks execute as real search processing language queries piped through the official Splunk MCP server. When a threat is verified, Gemini populates a security incident brief directly inside the Splunk dashboard, giving the operator an immediate, explicit verdict to block, investigate, or monitor the suspicious activity. Observability and security are handled through a single, unified defense system that identifies structural decay alongside malicious attacks. By identifying failures before they occur, the operational timeline achieves a negative mean time to detect, negative 15 minutes. The problem is flagged, scoped, and diagnosed before it formally starts. Consequently, the mean time to resolution drops from hours down to just 1 minute. AI-guided single-click approvals replace complex manual triage. We can quantify this impact in the system's prevented incidents ledger.
My Financial Tracking calculates the avoided downtime cost per event, with the current ledger logging over $1 million in saved capital. By shifting the focus from reaction speed to avoidance, these metrics provide a way to measure the reliability of a system based on its stability rather than its recovery speed. Combining Splunk Enterprise, all MCB server tools, the Python SDK, and Google Gemini creates a highly capable agent ecosystem. Stop reacting to the past. Fix it before it breaks.